Sample problem 2.16 wants us to use the periodic table to calculate the molecular mass of a couple of things here. So, the first thing to point out is where the molecular mass is located, right? And so, for instance, let's look at hydrogen. That number right there below hydrogen, 1.008, that's the molecular mass. And the units here on the periodic table are AMU, atomic mass units. So that's where we're going to find those numbers at. So let's jump into the problem. So A, tetraphosphorus trisulfide. It's much easier to calculate a molecular mass if you actually have the chemical formula for these things. So let's go ahead and write that in the formula form versus the name. So tetraphosphorus, so P4, right? The prefix tetra indicates 4. Trisulfide, so S3. So I've got 4 phosphoruses and 3 sulfides, or 3 sulfurs. So that's what I'm gonna do here. Let me find phosphorus first. Here's phosphorus number 15, 30.97. So 30.97 AMU, and I've got 4 of those. So 4 times 30.97 plus 3 times, let's see what the atomic mass of sulfur is. Sulfur, 32.06. 32.06 AMU. Okay, so I'm going to type that into my calculator, and let's see what I get. I've got 4 times 30.97 plus 3 times 32.06 equals, I got 220.06 atomic mass units for tetraphosphorus trisulfide. All right, now B says we have ammonium nitrate. Now that's going to be a couple of polyatomic ions, which means this is an ionic compound. So let me get us a little more room to work here. This one's going to be a little bit different than A because the formula is not so obvious just with the name. We don't have those prefixes to help us out. We have to look at charges to figure out the number of these things that we have. So ammonium, if I look at my table, that's NH4 with a +1 charge, okay? And then nitrate, if I look in my table of polyatomic ions on page 68, table 2.5, that's NO3 with a -1 charge. So the formula is going to be NH4NO3, right? The common factor between 1 and 1 is just 1. So I need 1 of each of those so that I would have +1 plus -1 to equal 0. All right, so now let's start adding up these masses. If I look at nitrogen over here on the periodic table, right, it's 14.01 atomic mass units. And if I look at my formula here, I have 2 of those, right? I have 2 nitrogens. So I'm going to have 2 times 14.01 atomic mass units plus, I've got 4 hydrogens, so 4 times the atomic mass from the periodic table is 1.008 atomic mass units. Plus, we have 3 oxygens, so 3 times from the periodic table 16.00 atomic mass units for oxygen. So let me type that in my calculator. 2 times 14.01 plus 4 times 1.008 plus 3 times 16 equals, and I got 80.05 atomic mass units for the ammonium nitrate.